All right, welcome back. Today we're going to start on conditionals, but before we do, we need to just tie up some loose ends from your lab yesterday. We started talking about command line arguments, and you were then exposed to them in your lab, and you had to convert a bunch of things to use command line arguments. I just wanted to go over those in a little bit more detail that we weren't able to get to on Tuesday. So in the context of C, first of all, interactive input where you prompt for user input and then you use scanf to read from the standard input, the keyboard. That makes a program pause and wait, basically blocking the execution of the program until the user enters their input and then hits enter. Most programs, especially command line programs, are not interactive. The vast majority of software is not intended for users. Now, like human users. Now, consumers, of course, they think that that's all there is, right? Their iPhones and their graphical user interfaces and stuff like that. That's just the tip of the iceberg. The vast majority of software is to automate things. That's the whole point of writing software. So that's the vast majority of software out there. From the command line, you can provide non-interactive inputs by providing them when you invoke the program. And in the Unix world, this allows you to basically pipe a bunch of things together. You can have a bunch of small utilities, something that sorts something that, another utility called awk, that I want the fifth column of this file or whatever. You can take 5 small programs and string them all together without having to do one single line of code. And the way that works is all through the command line, okay? CLAs are provided when you start a program. So if I go in the context of C, a.out, hello 10 3.5, that actually has 4 command line arguments. Okay, again, C, 4 command line arguments. The first one is always the executable file name, in this case a.out. Then the subsequent ones, those are the ones that are user provided. Inside of your program, you have access to these using argc and argv. Argc is the count of the number of arguments. So if they don't give you the correct number of arguments, you can check for that once we have conditionals and issue an error message and then quit on them. Right? Argv sub 0 is always the first one, or the executable file name. Argv sub 1, argv sub 2, argv sub 3, and each one subsequently after that, those are the other arguments that are actually provided by the user. Unfortunately, CLAs are strings only because people type these things. They're not numbers. They have to be converted to numbers for you to use them. In C, we can use A to I and A to F to convert them to numbers. All right? A to I, the difference there is if you want to convert it to an integer, if you expect an integer. A to F, that converts it to a double. Right? And you can see the usage of those two things here. So really quickly here, all I wanted to do is take our C version of the kilometers to miles program, and let's go ahead and convert it so that it uses command line arguments instead. Okay? So instead of this prompting and reading the input from the standard input, the keyboard, let's go ahead and change it. So I will expect miles as my first command line argument from the user. Miles is equal to A to I or F in this case? F, because we want to convert to a double, right? And what do we want to convert? Do we want to convert that actual first command line argument? Not in C. Remember, that's going to be a.out, right? If I go a.out and then I provide 10.5 miles or whatever, right? Then that's going to actually be 1. So let's see this in action now. KMS to miles, right? And run it. All right, so is anybody going to come out and run with us tomorrow? We'll be going 3.1 miles, which is 5K. Right? Okay, fine. Can we break it? How could we break it? This is part of your lab yesterday with the birthday program. Can you give it bad inputs to break it? February 31st, right? Spell it out. So 3.1, right? Or just 3, let's just say 3, right? 0 and 0, does that look right to you? Nope. What's another way that we could break it? And by the way, why is it 0, 0? So you gave it THREE. So what A to F is doing is it's saying, okay, you want me to convert a floating point number. All right, I'll start at the beginning. Oh, T? That's no number I've ever heard of, so I must be done. What have I parsed so far? Nothing. What's the numerical value of nothing? 0, and that's why it's 0 and 0. Yeah?
Can you add code into that? Like a malicious injection or something like that?
Not easily. I mean, you could some way maybe exploit that command line argument and try to force a buffer overflow of some sort, but your program is operating in user land, and who's responsible for making sure that your program is well behaved? The operating system. So when you do code injections, you're more than likely trying to circumvent the checks that the operating system has, not an actual individual program. Right? How else could we break it? By not providing any command line arguments. What's going to happen here? Syntax error? It's already compiled, so the compiler is done with its job. Right? Compiler said everything's fine, go ahead. Not enough arguments, sure. Segmentation fault. Segments of memory that don't belong to you cannot be accessed. This is the operating system saying, no, you can't do that. Right? That's not memory that belongs to you. So I will fault you out. You cannot access memory that doesn't belong to you. What's going on here is that I'm trying to access this argument that doesn't exist, and that's what seg faults it out. So let's add some code really quick here to tell the user, give the user a little bit better feedback. Do you want the end user saying, oh, I got a segmentation fault. I guess I better fire up my debugger and start coding C if this is just some random person off the street just trying to convert miles to kilometers, right? Probably not. Let's give them an easier message. So that requires conditionals, which is what we're going to talk about next. If the number of command line arguments that you receive is not equal to 2, remember we're only expecting 1 from the user, but we need 2. Why? argv of 0 is that executable file name. So it's actually 2. Right? We'll go ahead and print an error message. Printf error, please provide a number of miles, whatever. Right? And I'm also going to rudely exit on them. Don't worry about that 1 for now. That's how you can exit out of a program. It doesn't matter what code comes after that, the program is done. Right? Now let's go ahead and compile this. There we go. A.out. Now when I don't provide any command line arguments, now it results in that more human-friendly error message. You got to give me something here to actually process. Okay? Let's do the same thing over here in Java. Okay? I'm going to take away this prompt and read interactive input. How do we do this in Java? We have args instead. We don't have argc. We'll talk about argc here in a moment. But that's because in Java, the size of an array, these are arrays, the size of an array is stored as metadata in the array. So we don't need 2 arguments. Instead, I just want to convert the first command line argument. So miles is equal to, now here's how it's done differently. Instead of A to F, we have double.parse double. Right? How do you think we do integers? Not A to I, integer dot parse int, right? Okay, and I'm going to go ahead and convert the first command line argument. Here's another difference with Java. The first argument is not the executable file name. You've got that right here. Right? If you don't know what you called your own class, then there's something wrong with you, right? I called it KMS to miles. You don't need to store that somewhere else. Over here, we did need that information because with I could move that executable file A.out into myawesomeprogram.exe, right? And it would need to be provided as a command line argument. But over here, Java, you're the one that wrote it, man. Right? So it's the first command line argument. Let's run this. Uh-oh. I didn't provide any command line arguments, right? Because it doesn't look like I'm at the command line here anymore. So technically you're not, because this is a full integrated development environment. How do I provide command line arguments in Java? You hit this down button here, and you go to run configurations. Right? This is Eclipse, I should say. But any IDE will support something like this. And over here, second tab, you've got arguments. So what are my program arguments? I'll go with 10.5 and run it. Right? And there, I can convert 10.5 over to 16 kilometers. Right? Okay. What if I wanted to add the same check here? If args, now I don't have argc anymore because it is stored in the actual array. Dot length is not equal to, and now I don't use 2 anymore because again, that's a difference with Java, that the first command line argument is not the executable file name because you're the one that named the class. So if it's not equal to 1, then you didn't provide me enough arguments to continue to process, so I will go ahead and go with system.out.println error. You should give me data. Right. In fact, we can go one better here. Instead of the standard output, you saw what it was before. It was red, error, error, error. There's also a standard error output. And now our message here, error, you should give me some data, is going to appear in red, at least in Eclipse. Right? And we can also exit on them. System.exit. And now this will work exactly the same because I provided arguments. But let's go ahead and change our run configuration. Get rid of it. Apply that and run it. And you can see the error message here. Error, you got to give me some data. All right? So again, the key differences. What are the key differences here between Java and C? In Java, the arguments are provided in the array args. Right? There is no counter, there is no argc. Instead, use, what was it? args.length. Right? The first one, the first argument, is the actual first user argument, not the class name. Right? So you start everything at args of 0. And the final difference was what? Oh, and the conversion. To convert, use. What was the first one that we used? Double dot parse double. Right? Dot dot dot. You put whatever you're going to parse inside that. The second one is going to be integer dot parse. Oh, I gotta spell my double right. Yeah, it would make sense if it were parse integer, but it didn't. What is it? It's just int. Right? I think that's more to match the primitive type, small I integer. Right? These things are called wrapper classes, double and integer. And they have a bunch of other utility methods that you can call on it, like to convert it from a hexadecimal or to output it to hexadecimal, to do a bunch of other things. Right? So they're very, very useful. They are wrapper classes in that the primitive types, the small d double, the small I int, those are just numbers. These things are numbers, but also they have methods that you can use. Right? We'll talk about the difference later on. Questions on the basics so far? Yeah.
Check line is the H and done.
Oh.
Third line.
A third line?
Yeah.
Oh, okay. All right. At least I didn't spell it te. Right. Small typos, don't worry about that. Doesn't gotta look pretty. Right? Okay. Well then, let's start talking about what we just did here. This is a conditional. Most of you have probably seen it, and you can probably understand it just because of plain English, right? If this condition, then do that. Otherwise, do something else, right? Those are conditionals, okay? And let me go ahead and fire this up here. Markdown, open, and zoom. And by the way, there was I think that there was a thread maybe on this class or the other class on what do you suggest for text editors native text editors instead of if you want to use Eclipse, if you want to use the CS50 IDE. My personal preference is that I've been using Atom.io. Atom.io is free, and that's what is actually rendering this markdown. So it's now owned by, well, it was always owned by GitHub. GitHub is now owned by Microsoft, so maybe they'll tank it because they want everybody in Visual Studio. Who knows? But hopefully not. All right. So programs usually have normal linear control flow. If you've got a statement 1, statement 2, statement 3, then it goes in that order: statement 1, statement 2, statement 3. It's top to bottom, left to right. But more complex programs require you to make decisions. It require you to tell the computer to make a decision based on some condition. Both C and Java support else if and if-else if statements. They're all basically the same thing. There's one of them is the other one in disguise. Each one relies on some logical statement. A logical statement is a statement that is either true or false. There's no in between. You may not know what the truth value of it is up front. That's why we can have Boolean variables. It could be true or it could be false. I don't know. We have to run the program first, right? But ultimately, when it is evaluated, it has to be one or the other. It's not something in between. It's not a half-truth or 0.5 truthiness or whatever. The Boolean statements can also be used. Statements that are values that are either true or false, right? So I'm going to assume that we have, I'm just going to go ahead and give you the syntax here. This is both languages here, right? Now, this is not real syntax on the conditions here. Clearly, this is not real code in either language. But note here the keywords that we use: if, right? So if this condition evaluates to true, then this code block right here, everything in that code block is going to execute. If this condition is false, then nothing inside this code block executes, and normal control flow, sequential control flow, continues after the if statement. Some style tips here. In both languages, there is no space between the if and the parentheses. I've put a space here and an opening curly bracket on the same line, and I've aligned my closing curly bracket with the I and the if. This is one style that I would suggest that you use. There are some other styles where, alternatively, you can go ahead and put both the opening and closing on the same line. It looks a little bit weird to me, but it doesn't matter. Your style is your style. You'll eventually have to adopt a style guide anyway, as long as you are consistent about it. Right? Now, that condition is not a real condition. We have to put something in there eventually. Okay. Alternatively, you have an if-else statement. Oh, yeah, go ahead. Okay. Alternatively, you have an if-else statement where you've got a condition that can either be true or false, just as before. If it's true, everything in code block A executes. If it's false, everything in code block B executes. Those are called mutually exclusive. They exclude each other. Either block A executes or block B executes, but it's not the case that both of them are going to execute, and it's certainly not the case that neither of them executes. It's one or the other. They mutually exclude each other. And also, again, notice the style here. All of the closing curly brackets are are aligned with the I. The else is right in between the opening and closing curly closing and opening curly brackets. And again, that's the style that I would encourage you to adopt. It's kind of a standard style. Yeah.
So you mentioned that there's no space between parentheses and if in the if statement.
Yeah, that's the style. It's just generally white space doesn't matter. You can go ahead and put as much white space as you want there, but you shouldn't. Right? If you're going to put some white space, at most one space is usual. But why? More spaces. I mean, if and then it immediately. This style is kind of like treating the condition like a function, like square root. You also use parentheses, and that immediately follows. You can put. Not a good idea, but I believe that you can put a bunch of white space in there, but it separates the thing from the thing that it operates. And we want those close together so that we know that this if is operating on this condition.
So what do you suggest for else if statements?
Same thing, but with the else if, no spaces. We'll get to that in a second. Yeah. Yeah, go ahead.
So to make sure that that if and the else are like in the same condition, do you have to put that else one space directly after that?
No, the white space doesn't matter, but the curly brackets certainly do. And note here that even if it's one, I will always put, the good style dictates that you should always have the curly brackets, even if it's not, even if it's only one statement. Simply because your intentional code, clear code, is much better than I don't want to put in curly brackets, right? We'll get to that as a pitfall later on here. Okay. Okay. So let's go ahead and oh no, I don't have examples here. Okay, fine. Let's go with from the main section. I did cut and paste it in the main section. All right. So let's go ahead and go with the demo file here. All right. And let's start doing some if conditions right here. To do that, I'm going to, of course, need some variables. So let's go ahead and go with int a is equal to 5, int b is equal to 10, int c is equal to 15. Okay. Now, I'm just going to keep this purely numerical. I want to compare a few things. So if a is equal to 0, uh-oh, why did I use two equal signs here? Why didn't I use one equal sign? Yeah, that's reserved. That's already the assignment operator. That already has a different meaning. So what do we do? All right, well, that's already reserved, so I guess I'll go ahead and go with 2. Right? There are some programming languages, by the way, where you do 3. Dynamic, not C, not Java, but dynamic programming languages that need both loose comparisons. Do these things have the same value? Maybe not necessarily the same type, so that you can compare numbers to strings. But oh no, I want strict comparison. I want to know that they're the same type, they're both integers, and they both hold the value 5. Then you need a third one there, right? That's other like JavaScript, PHP. Those are just the two off the top of my head. Maybe Python somehow. I'm not sure though. All right. Then I'll print f do not divide by a. Why wouldn't I want to divide by a in this case? If a is 0, can you divide by 0? Nope. In fact, I wonder what would happen. Let's go ahead and do it anyway. All right. Int d is equal to b divided by a. Of course, I'm going to need to change it. And then let's print it out. 2 birds with 1 stone here. We'll see how this operates, and we'll also see what happens when you do divide by something like that. So %d is my placeholder, and I'll output d. Right. So let's go ahead and compile the demo here. What are you complaining about? Oh, /n, not n/. There we go. All right. So first of all, predict. Will it print anything? Remember, I did change a to 0. So is it equal to 0? Yes. This will evaluate to true, and therefore this code block will execute. Let's go ahead and run it. Do not divide by a, because you get a floating point exception. Right? Now that was not a fatal exception. I don't think that killed the program. It's just that there was nothing else to do after that. Right? But division by 0 is a floating point exception. If we tried to, I guess maybe it was because we never ended up printing anything, right? Print d is equal to, let's recompile it and see if we can even get that. No, it killed my entire program because I divided by 0, right? Okay, so I won't do that. Fine. You can, and is this big enough for everybody in the back, or do I want to zoom in? Okay, a little bit. You can, but shouldn't, do the following. If 0 is equal to a, then the exact same thing. Right? Now, that logically, that's exactly the same thing there. A is 0, then you execute this. 0 is A, you execute this. But read it aloud or in your mind here. I'll read it aloud, you read it in your mind. If A is equal to 0, then do this. The second one is, if 0 is equal to A, then do this. Which one seems more natural? Does the second one seem weird? Yeah. So don't write weird code. If you are comparing a variable to a literal, make sure that the variable comes first. Right? That's just style. Bad style. Okay. Okay, you can also compare two variables. You can compare two variables. For example, if A is equal to B, then I'll print both are the same. Right? Or I can put in an else statement, else, printf, A and B are different. So what's it going to print? That they're different, of course, because one is 0 and one is 10. Yep, there we go. Excellent. You can also have entire expressions. Oops. You can use entire full mathematical expressions. For example, what if I go with if b times b minus 4ac is less than 0, right? Is that correct code right there? No. Can you write it like this, 4ac? In your math class you can, but then this isn't math class, right? This is proper computer science. This is proper programming. Yeah?
Is there an exponent operator?
No. So, aside here, sometimes programming languages allow you to go a to the b, right? Neither programming language that we're looking at allows you to do that. That is a bitwise exclusive OR operator in both languages, I believe. Some languages allow you to use ** as the exponent. C, Java, no, right? Instead, what do you need in C? A math library, POW, A to the power B. What about in Java? Math.pow. And that'll do it for you. Right. Now, if it's something simple like, say, b squared, why bring in a math library to complicate things? Just b times b, right? So what am I checking here, by the way? The quadratic formula, the radical under the quadratic formula. If it's negative, can you take the square root of it?
No, there's no real root.
There's no real roots. So let's print that out. Print out no real roots. Yeah. There we go. Right. And so you have to bring in a library that supports complex numbers. There are roots. It's just that they're complex roots, right? Xi plus y. And I comes into the equation there, okay? Okay. You can also use other expressions. Test if A is odd or even. How could I do that? Mod, right? Remember this thing? Mod. And if you mod out by 2, there's going to be there's going to be a remainder of 0 or 1. If it's equal to 0, if that remainder is equal to 0, then it's even. If it's not, else, it is odd. Old. Odd. There we go. Forgive me for my typing today. This is the butterfly keyboard. It's my third one, and my D key has fallen off. So, and the A and the C are not far behind. Right? So let's go ahead and run this and see if it works. Yeah, it's even. Why is it even? It's 0. 0 is an even number, right? 1 is odd. 2 is even, right? Even, odd, even, odd, even, odd. Okay? So you can test whether or not something is even or odd. You can, but shouldn't, do something like this. If 10 is equal to 20, then print f. Printf. What a world. 2 plus 2 is equal to 5, right? So why shouldn't you do something like that? Is that ever going to be true? No. This is something called a contradiction. This is a contradiction. This will never execute. This is dead code. Dead code is bad code. Dead code is messy code. Dead code is cruft. We've talked about cruft before, right? The cruft hall, the hall that you throw all your junk in. Don't do that, right? If you want it to print what a world, or if you don't want it to print what a world, don't write that code, right? Also, don't do the following, right? If, say, a is equal to 0, then we'll printf, yay. Right? Otherwise, else, well, I don't know what else to do. I'll do nothing. I'll just leave that blank, right? Don't do that, right? Bad style. Why is this bad style? We've got cruft here. If you've got a blank else, right, why did you write that? Right? Just get rid of it, right? The program will move on just normally, okay? What's something else that you shouldn't do? If a is equal to a, then print f foo. That's not a contradiction. That's something else. That's something that is always going to be true. And if something's always true, what is that called in logic? A tautology. Right? Maybe we've not heard of that yet. It's a tautology. Right? It's something that's always true. Don't do it. Again, bad style.
Is there style practices for expressions, like the white space and stuff?
The good question. Are there style, like for example, this? I didn't put a bunch of, some people would put spaces in between everything like that. Like that. Some people would also put, say, spaces between the parentheses and whatever you're putting inside of it. Horizontal white space, I don't know. That kind of looks less readable in my opinion. Because you've monotonically spaced everything out exactly evenly. That b squared and that 4ac, that's something a little bit different, right? And then you take the difference of them, and that's why I would prefer, personally, I would prefer gathering all those things together. Fine, go ahead and space it out on either side, but that seems like the best of both worlds right there.
Yeah.
So whatever your style is, I don't know what, I don't think that a style, remember that tool that we used, is going to do anything with this, with the like horizontal white space, only vertical white space. A style demo. Oh, okay, it did prefer that, but that's just it being, you know, I'm going to do the same thing for everything regardless, right?
Did it change it?
Yeah, it did, didn't it? Yeah. It spaced it all back out monotonically. Right. To each his own. Okay. So I will make sure that you have this in the notes, since I didn't have it over there. So let's go ahead and go with examples. Examples, and then these are all C. And by the way, what would be the only difference if I did this in Java? Let's find out. Let me go ahead and just create a new file here. Remember to create a new class, just new class, demo. And if you don't like writing that public static void main every single time, click that button right there and it will generate the code for you. Right? And with a to-do, with an automated comment there. Right? So what's the only difference? At least what's the only apparent difference now? System.out.printf. Okay, fine. Printf. Replace all those with system.out.printf. Replace it all. Good. Done. Except that now let's go. Everything's fine up until this point. Now this is a warning. In fact, what's the warning? Can anybody read that tiny print up there? Dead code. What did I call it? Dead code. Cruft. Right? It's dead code. Don't do that. It's just a warning. Fine. If you want to put dead code into your program, we'll go ahead and do that for you. Right? The compiler might compile it away, and it might not end up in your executable program at all. In Java, I'm not sure that it would do that. It would still be in your Java class. It's just something that would never, ever execute. Right? Something else, it didn't complain about this style, but something else that it complained about here is comparing identical expressions. It didn't call it dead code here because it's not dead code, right? This is always true. It's a tautology. So no matter what, this is going to execute. But it is giving me a warning here, right? Okay. Otherwise, everything and syntax-wise is exactly the same. Yeah. Sure. It was just more, for me on a Mac, it's going to be Command F, and then replace is right below it. Right? And I believe that you can go ahead and go with a full regular expression if you know those. If not, it's a super useful tool. Pick it up when you can. Right? Regular expressions. It allows you to detect all things that look like phone numbers, right? Or it allows you to detect everything that starts with a number and ends with a number, and replace all those things and stuff. Right? That's just the tip of the iceberg there. Yeah.
So if you're comparing more complex like equations inside these parentheses and you need to use like a parentheses for your equation, you just use them like normal.
Oh yeah, you can write parentheses until the cows come home if you want. In fact, there's a programming language called Lisp, L-I-S-P, and it's short for, it's a shortened portmanteau of list processing. But really, people call it lots of silly parentheses because the entire language, parentheses, parentheses, parentheses everywhere. Because it's a functional programming language where you have no variables, you just have expressions. And you take the result of one expression and put it into another expression and write parentheses around everything, right? So, I mean, like if I were to do parentheses right there, no, that's not necessary. Only use parentheses in like programming languages like Java and C when one, it's absolutely necessary for correctness, and two, it makes your code more readable, right? Okay, good. And you've got all the examples there that I just gave. I marked it up in C though instead. All right, let's see. So again, they're mutually, I'll go ahead and copy this over. There we go. So the if statements, again, are mutually, if-else statements are mutually exclusive. One happens, but not the other. Never both, never neither, right? There we go. I got that double negative out. You can also generalize it to an if-else-if statement. But in general, that else block is optional. In fact, if we go back up here to the original, this is the same thing as this with an empty else block. But like I said, stylistically wise, if you've got an empty else block, just don't write it at all. In which case, you've got a traditional old if statement here. Okay? Then you can generalize that to if-else-if conditions. Let's see. And this is the same in both languages as well. If some condition, condition A, then block A. Right. There we go. Else, and then you can add another if statement here. Conditional condition B, and then block B. And then you can add, that by itself is perfectly fine. The else condition, the else block is always optional, but you can go ahead and add it here if you really want to. Block C. All three of these things are mutually exclusive. Right? Now, here's the dirty little secret. There is no such thing as an else-if statement. If, else, all we're doing is attaching this if-else to that end of that. Right? So syntactically, there's no such thing as an if-else-if statement. It's just a bunch of if-else statements strung together. Right? You can have as many conditions as you want. You can have as many blocks as you want. Right? You could, if I had 10 blocks, I would need 9 conditions to determine which one of those things should run. They are all mutually exclusive, and therefore the order is important. Right? What I mean by that is, let me give myself some more room here. Text. There we go. Ignore that. There we go. The first condition that evaluates to true is the only one that actually gets executed. Okay? So order becomes important. You want the most specific conditions first, and then you work your way to the most general. In fact, what's the most general? It's the else block. This condition didn't happen, this condition didn't happen, this condition happened. Well, what else is there, right? By deduction, it must be this thing right here, and that's the most general situation that you would have. So if you've got multiple conditions, you need to make sure that you're ordering them correctly, okay? And we'll see an example of that next week. Again, the else is optional, right? And in general, you start with the most specific conditions and end with the most general conditions. Now, we've seen the numerical operators before. I just gave a preview of it in this demonstration up here. But of course, you have strictly less than, strictly greater than, less than or equal to, greater than or equal to, right? And that is how you read them. These two are, of course, natural. But these two, you don't have them on your QWERTY keyboard, right? You don't have the traditional math symbols of less than with an underline below it, right? This thing is what I'm talking about, right? We all know this thing, right? Less than or equal to that thing, right? Or greater than or equal to. There we go, that thing, right? Or not equal, right? We don't have those things on our QWERTY keyboard. So what do we do instead? We have equality. And again, as we already said, that's going to be two equal signs in both languages. We have the inequality. That's going to be, instead of, we don't have it on our QWERTY keyboard, we can't cross it out. So it's going to be an exclamation point and then the equal sign. Granted, we have other things that look like that cross out, right? We have, we have this, is that a backslash or forward slash? Backslash. We have forward slash, right? We have this thing called a pipe or a Sheffer stroke, or just call it what it is, a vertical line, right? Why didn't they use those things? Those things have other meanings, right, in the language already. So when you've only got the QWERTY keyboard, you start running out of characters in plain text, so you make do with what you have, right? Not equals. Right? It's a very excited not equals. Right? And in fact, it can be used in other places. It's the generalized negation operator. You can take any logical statement and you can reverse it. True becomes false, false becomes true. You can negate it by simply just putting an exclamation point in front of it. Let's look at some examples. A is less than B, right, is true if and only if A is strictly less than B, right? What would we do if we wanted to negate that? So it is not the case that A is less than or less than B. You've got to be careful here, right? If I write it like that, what am I negating? I'm negating A. Now, in Java, that's not going to be allowed, but in C, it's perfectly fine. We'll understand why in a moment here. So I don't want to negate one variable. I want to negate that expression. So here is an instance where I need to put in parentheses. It is not the case that A is strictly less than B. But equivalently, what could I have written instead? Yeah. Oh, okay. So, you want to do negation on this? Okay. That's not going to be syntactically correct in either language, but how can we reinterpret it? What if something is not strictly less than something else? Then it must be greater than or equal to. So I should have written like this instead, right? So here's our first alphabet soup, or maybe our second or third alphabet soup. KISS principle, right? Which one of those is better to write? It is not the case that A is strictly less than B, or A is greater than or equal to B. Which one of those is simpler? The second one. So keep it simple, stupid, right? It's not just in code, but it's in everything. Simpler code is easier to read code. Easier to read code is, it's better style, right? The compiler might see this and it'll take care of the optimization for you. As far as efficiency goes, that's not an issue. What the issue is readability and understandability, because code is for other humans to read. Binary is for machines to read, right? We need to make it more readable, right? Let's see. Okay. All right, those are the numerical comparison operators. In neither, in fact, I will emphasize that 3 stars there. It is both italic and it is bold. And I wonder what happens if I do all 4 stars. Okay, no, never mind. I was hoping that it would have underline. In neither language can you use the equals equals nor the not equals for strings. Okay? You just can't do it. I mean, you can, but it's not going to give you the results that you want, right? It does not compare the contents of strings. Instead, using these with strings compares the memory address of the stored strings in both languages. Right. So, let me show you as a demonstration here. All right. Over here in Java. Right. What I'll do is I'll create 2 strings. String A is equal to hello, and string B is equal to hello. Okay, if A is equal to B, then print system.out. Println strings are equal. Let's find out what happens here. Cross my fingers here. It actually might output that they are equal, even though it's for a different reason. All right, yep. The different reason being the Java virtual machine, the Java compiler sees you've got string hello, A and B. Why am I going to make 2 different strings with the same content? I will make one string hello, and I will make both A and B reference it. Right? That's the compiler optimizing away my demonstration code here. So what I'm going to do is I'm going to force it not to do that. New string. There we go. Now, these are definitely, I'm crossing my own fingers here, these are definitely going to be different things in memory. It was true before because they were the same things in memory. That equals equals is comparing memory addresses. Right? And let's go ahead and now it goes away. Even though they're the same content, right? Both of them are still hello. If I were to print them out, you would see hello, capital H, and hello, capital H. But they're not the same memory addresses anymore. Okay? All right, there's no way for me to show you the memory address of a string in Java because the toString method is already overloaded, but I'd have to make my own class, I guess. But anyway, so you can't do it. What would this look like over in C? Now, we're not going to get to C, strings in C until much later, but here is a quick preview. We don't have strings in C. We have chars, right? And we have character arrays. And I'll do it like this. And if A is equal to B, then I don't have system.out. I have printf. There we go. Let's go ahead and let's see what happens here. I'm curious actually as well. It actually compiles, okay. What's it going to do? What do you think? Strings are equal. Again, it's the compiler doing this for me. So what I'm going to do is I'm going to make this into a different string, a statically allocated string. There we go. They're not the same thing, even though they have the same content. If you want to compare content, you need to use something else. Yeah?
So is the R&B like a 2-dimensional array?
Yes, excellent. Good job. Okay, so you observed that a single char is a single character. This star here then must be multiple characters a string, right? An array of characters. So what is star star? It must be an array of characters, right? And yes, that ends up being an array of strings or a 2-dimensional array of characters, right? Here's the first string, second string, third string. Imagine it as a matrix. Much later, right? Actually, in 6 weeks. Right? Okay, but you can't use the equals equals operator here. Okay. All right. All right. Let's see. Boolean variables. There we go. Any questions so far? Otherwise, Again, as an honors course, I'm not, because we're covering two languages and highlighting the differences between the two, I'm kind of going a little bit faster than I would in the main section. So if anything ever needs clarification or we want more examples or anything like that, please let me know. Right? We will be ahead a little bit because they won't have a course on Labor Day. Right? So often you will have need for variables that hold the values true or false. Right? No questions online yet? So for example, right, you can have what are called flag variables, right? Like is student, or done, or is freshman, right? Et cetera, et cetera. Note here I'm putting in is, which is what, a transitive verb, or state of being would be an intransitive verb, or transitive verb, intransitive verb, right? So intransitive verb, they are a student. This person is a student, right? That's how I'm labeling these things. If instead I did something like this, student, that tells me that that variable represents the actual student entity or the idea of a student. By putting an is in front of it, that has a different meaning, a different interpretation. They are a student, right? Are student doesn't sound right because you're only talking about one, right? So take what you know from grammar and apply it to your style with C, right? So in C, unfortunately, there are no Boolean variables. Right? You can in C, you can bring in a library called stdbool.h. What do you think the stdbool stands for? Standard Boolean, right? And you can then which has the keyword which has placeholders for true and false. Right? But despite the name Standard Boolean, it still does not create a Boolean variable type. Instead, in C, true or false, excuse me, false is associated with, or no, let me start out with differently here. Boolean variables are numbers, right? We're just going to reuse integers basically, right? We reuse int variables. You can use doubles if you want, but you shouldn't. You can use chars if you want, but you shouldn't, right? False is associated with 0. True is associated with, what do you think? 1 is the most common, right? But think about negations. If I negate, if 0 is the only thing that is false, and I negate it, what must be true? Everything else, right? Is usually with 1, but any non-zero value is true, right? 42 is true, 1 is true, 42 is true, -5 is true, 3.14 is true, are all true. And that's how it works in C. Do not make any assumptions about that, right? Understand that you can use 1, you can use 0, but don't make any assumptions about it. Don't assume the value of true. Because it could be, I'm going to go ahead and use 42 because I like to be different, right? I like to write squirrely code. So I'm going to use 42 as my truth value everywhere. If you go and make the assumption that 1 is the only thing that is true, then it's not going to work. Let's go ahead and come over here and see what I mean. So int is student is equal to 42. Bad style and incorrect. I want to check if they're a student because then they get a discount. If is student is true, 1, then printf, you get a discount. You get a student discount. Is it going to run? I mean, is it going to tell you that you have a discount? Even though The student is they're 42. Of course they're a student, right? True. Nope, you don't get your discount. If I did 1, then yes, but that would only assume that 1 is the only thing that is true, right? So, how do we fix this? We don't use the equality operator. Better style and correct in all instances. It would be if they are a student, is student, then print out you get a discount. And no matter what, this will work. If it's 42, if it's 1, if it's 3.5, in all of those other instances, it'll end up working. How do I set it to false? 0. Now nobody gets a discount. There we go. Right. And just to show you that I was not lying, you can actually bring in the std bool library. The only thing that this buys you, though, is that you can start using the keywords true and false. Right. So let's set it to false. Otherwise, everything else is going to be the same. Right? Again, you shouldn't do this. You shouldn't either do something like this. If it's equal to true, that's really weird. Again, kiss. That's cruft. Right? This is much more terse. Right? It's shorter code, and therefore much more readable code, much more easily understood code, quicker to be understood code. But did I compile it? There we go. Run it again. And I can set it equal to true. In both of these instances, it will end up outputting you get a discount. Okay? That's C. Yeah, go ahead.
Is this stored as an integer, or?
It is stored, well, that's what I created it, right? It is still an integer. So it's 32 bits. If you want to, you can create a byte. There is no byte type in C. You can use a single character. But now everything in the ASCII text table is true, including no and F and all that other stuff, except for the first one. The first one is a special character called the null terminating character. It's the only one that has a value of 0. That's the only one that ends up being false. So you can use a chart. You can use whatever you want. I think maybe even they might have supported this. Let's find out. Yep, it does. All it is an alias. It's still going to end up being an integer. It doesn't actually create a new type in the C programming language.
So if it's double, it's also
Yeah,
not,
yeah.
not zero, it's true.
Yeah, you get yourself into big trouble when you use a double because you can have negatives. Well, you can have something that's almost 0, no, the floating point issues become a huge issue at that point. So there we go. That's in the notes. I'm just going to cut and paste that over here in Java. All right. So we do have the keywords true and false in Java, but Java was able to afford another variable type. It didn't have to go and borrow and reuse an integer like C did. Instead, they have a full Boolean. It's not bool, right? It's not shorthand because they're not paying by the character. Boolean is student. And you can set that equal to true or false. Right? System.out.printf. There we go. And there we go. Right? And you can run it again. You get a discount. You get a discount. You cannot use an integer value. For example, if I did that, int is freshman is equal to 0. If I tried to use this convention, I would not be able to use this in an expression here. If they're a freshman, you get a bigger discount. Right? It's not even going to compile. You see that? It says type mismatch, cannot convert from int to Boolean. We can afford Booleans in Java, right? Don't do the hacky way that C does with an integer variable here, right? So this is not even possible. And again, I will make sure that you've got this in the notes, right? And Java has actual Boolean type variables that you need to use. It's not an option. There we go. All right. Questions so far? No? All right, then in our last few minutes here, let's go ahead and try to breeze through this. Logical operators. So you can combine more than one statement to form more complex statements. And you can use the logical AND operator or the logical OR operator. And there are a couple others, but we're going to focus on these two right now. For the logical AND operator in both languages, it's going to be the ampersand. It is not a single ampersand. You might write code, and you might even see code where you can use a single ampersand. It has a different meaning. It is a bitwise AND operator. So it operates on each bit in a bit string, or in an integer, or whatever type you're trying to do. It is not going to result in true or false. In C, you can go ahead and use both interchangeably and get completely different results, not what you intend. In Java, you can only use, you can't use the single ampersand in a logical expression. It does not result in true or false. Right? It results in a new bit string. For both languages, it has the same meaning. Right? For example, A and B is true if and only if both A and B are true. Right? It is false when ... When is it false? Either are false, right? So to write that out and completely, A is false, or B is false, or both are false. Right? So there's only one of those. There are always going to be four possibilities, right? True, false, true, true, false, false, true, false, right? So four possibilities of matching up all those things together, right? The logical OR operator is true if at least one of its operands is true. Right? We use the syntax here. Most people are probably aware of it. What is it? Straight line, vertical line. Pipes, or Sheffer strokes is what they're called in mathematics. It is not the same thing as the single vertical line, et cetera, et cetera. All right, and again this is true if, or this, what is this? A or B is true if A is true, or if B is true, or if both are true. Right? It is only false when both are false. So it's not like the colloquial or, right? You can have cake or ice cream. The implication being that you can't have both. That would be called the exclusive or, right? And the exclusive or operator, we already know what that is. Not equals, right? So you can have cake or ice cream. Cake, but not ice cream. Ice cream, but not cake. Not both, not neither. You have to eat one of those, right? All right, fine, if you force me, I'll go ahead and eat it. All right. So there's something called De Morgan's Law that we won't get into. I'll just tell you as a fact here that you can take a negation, and this might be what you were referring to, that you can distribute it on a logical expression. For example, if they are a student and they are a freshman, but negate that, right? That's equivalent to taking this negation and putting it on the first one, changing an and into an or, and then also putting the negation on the second one, resulting in this expression right here. Now, that's equivalent logically, but which one is better to write? It all depends on what you're trying to do. Is a student and they're a freshman, so they must be a freshman student. Not the case. They might be outside the university. They might be inside the university, but they're sophomores. They might be inside the university, but they're non-traditional students or something like that. I don't know, right? Which one of these is more readable? That's probably up for debate, right? They're not a student, or they're not a freshman. Okay. It is not the case that they are a student and that they're a freshman. Wow. That's 6 of one, half a dozen of another. I don't know. Both of them are confusing, right? But they're logically equivalent. Right? I would say, at least stylistically, all things being equal, the first one is probably preferable because you write less. Right? Yeah.
But I still can't wrap my head around. So,
I can't either.
so
I have to pull somebody off the street and say, and are you a freshman? Yes. Are you a student? Okay, then not you.
it's only when is it true? If it's not
So this thing, when is it true? It's when this is false. So I'm pulling you off the street. Are you a student? Are you a freshman?
Okay.
Not you. So if somebody answers yes to both of those, I'll pull somebody off the street. Are you a student? Yes. Are you a freshman? No, I'm a senior. Yeah, okay, come on in. Right?
It's only true when one of them is true. The other
So inside the parentheses is true. They both have to be true. So the negation of that is that at least one of them is not true. And that's why you get this expression right here. At least one of them, or, is not true, not true. Yeah.
Does it work the other way around if you have a or inside the parentheses?
Yes, you can, in fact, just like a negation in math, right? A plus B, and then you negate it out front, then it's negative A minus, or plus minus B, right? But the plus and the minuses don't change. I mean, they technically do, but yes, you can distribute and then you can factor them out, right? Yeah.
But if both of them are not true, then it's still true.
If both of them are not true, then it's true. Yes, they are. There's some rando from downtown, right? Yep. Yeah, you get your discount or whatever. It's the freshman exclusionary discount. Everybody gets it but freshmen students. I don't know of a case where somebody would be a freshman but not a student. So I would argue that, and this is just a toy example, so I would argue you need to simplify that logic there, because if they're a freshman, they're automatically a student. Get rid of that first condition anyway, right? There's some like quantum student where they're in a state of being a freshman and not being a freshman at the same time, right? Okay. All right. So I'm going to introduce this, but I'll let you think about it over the weekend as you're watching football, right? Yeah. Okay. Well, you're lucky because I don't get BTN, so I'm going to have to think of something. Probably go over to somebody else's house, but whatever. Consider the following C code, where say that I've created a variable a here. Int a is equal to, I don't know, 5. Is this going to printf foo? Is that going to print, what is that going to print? Is it going to print foo or not? Let's find out. Okay, yeah, foo. Why? Because what's my intention here? If a lies between 0 and 10, well, 5 lies between 0 and 10, right? So it looks like it's okay. Yeah.
Can you compare between ints and doubles?
Yes, but then it gets hairy, because if it's 3 versus 3.00000001, they ain't equal, right? So the trick there is to build in a tolerance. What you actually want is if it's something close to what you're doing. So a minus b, where integer and double, take the difference, take the absolute value of it, and if that's less than some delta, right? If it's within 0.000001, then for all intents and purposes they're equal, right? And you'll see that later on when we do our own automated unit testing. We build in a tolerance for a lot of stuff. So as long as you're close enough, like to within 1 millionth, then your answer matches our answer. Right? So that is something of practical, use. But all right, give me another value. 15. Is that inside the range that I'm intending? But it still prints foo. What about at the other end? Negative 15. Still prints foo. This is a tautology. And as you're working on stuff over the weekend, I'm going to give you another tool here and then explain it on Monday. The wall tool. All right? And what was silent before ends up being, wait a second, what are you doing? Comparison of 10 with Boolean expression, this is the one you want to pay attention to. Comparisons like this do not have their mathematical meaning. Right? Math and code are different. And this is warning you about it. Right? So how should I have written this? And a is less than 10. I should compound that and spread those out. That is going to be correct. And it's not going to warn me about it anymore. And now it doesn't print foo. So, oh yeah, go ahead.
Wouldn't you change the first part of your if statement then?
That's a stylistic, I was going to get to that on Tuesday, but in this particular instance, rules are meant to be broken. They're not rules, they're guidelines. In this one particular instance, I'd say it's better to do it like this because you've got the lower bound, you've got the upper bound. But the wall flag here, it's not the wall like that's holding up the ceiling. It is the warnings. Turn them all on so that I can see potential problems with my code. This is something called a linter or static analysis, where you've got a compiler or a tool that can look at your code before it gets compiled and start looking for potential issues, or lint. Right? What is lint on your clothes? Is it dirt? No, because your clothes come out of the dryer, they're clean, right? But the lint is the stuff that's left on it. It's not dirt, but it's stuff that you probably don't want there. So let's take it off. They're not errors in your code, but it's probably stuff that you don't want there. Right? And that's called linting. Yeah?
So when we're doing 0 less than or equal to a, and then you put, or greater than or equal to, I'm getting myself all confused here. But when you had it the way you had it before, you put it in there, basically. Is that treating it as if there was a single word there, or is it something different?
No. What's going on here is C being C, where 0 is false and 1 is true. So if this ends up being true, it puts in 1. 1 is always less than or equal to 10. If it ends up being false, it puts in a 0. 0 is always less than or equal to 10. And that's why we got the behavior that we did. So this is not even possible. Let me go ahead and back up here. This is not even possible in Java. Right? System.out. Oh, forget that entirely. Java's not even going to compile that. In Java, it's not lint. It is actual dirt. So it's been elevated to dirt. Again, C is the kind of programming language that if you say that you want to shoot yourself in the foot, it'll ask you what caliber, right? And Java is a little bit safer. Other programming languages are a little bit safer or more dangerous or whatever. They're going to ask you, are you sure that you really want to do that? Okay, fine, go ahead, right? If you're explicit about it. Right? All right, have a good weekend. Have a good 3-day weekend.